Right, nice. You're hearing that? Good, 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 nice.
Yes, sir.
All right, so basically, last day we started limits, right? We said that a limit is written like this: the limit of x approaches a of some function is equal to L. Okay. If we have to prove a limit exists, like for example, at this point here, if we have to prove a limit exists at that point, we have to prove that as you approach the limit from the right and you approach the limit from the left, those two values have to be the same. Okay, so as you approach, let's say you approach a from the right, it has to be equal to the limit of x approach a from the left, right? Then we also talked about continuity, and we said that there are three rules to continuity. One, f of a must exist. Two, the limit as x approaches a must also exist. And third thing, f of a must be equal to the limit as x approaches a. Okay, so that's basically what we did last day. Yeah, so we did those little things last day on limits, on continuity, and we also looked at sketching piecewise functions. And I told you, let's say you couldn't sketch a function. Let's say you get something harder, right? Something looking like that, right? How do you figure out which? Suppose I gave it two functions, right? These two pieces here make up f of x. Just making up something, right? Suppose I gave you those two functions, and you had to check and see if it's continuous, right? Or to work out the limit. To work out the limit as x approaches a from the right, we always use which one? The more than or less than? Use the more than, right? And to approach from the left, we use the second function. Are you okay with that? So if you have to prove a limit exists and you can't sketch the function, then you're using the more than part as it approaches from the right, and the approach from the left, you are going to use the less than function. So in our example above, we will choose this function here. So plugging in there, plugging in that function as the approach from the right, plugging in this function as the approach from the left. Right? We're going to do a couple of examples of these, and then we're going to simplify limits. Okay? Right? Copy that down now. I don't think I know we talked about it, but I didn't do an example. Right? We're going to do an example now. All right, ready? So let's take a look at the little past paper here. This is 2009. Right? This is 2009. Let's just see how we'll handle something like this, right? Ignore the first, actually I'll cut out the first part. I'll show you that afterwards. Oh, as I was asking some of the face-to-face people, right? When I doing the crash course, you all prefer, remember it's 3 modules, right? Module 1, 2, and 3, right? You all prefer 3 6-hour classes. 3 6, oh wait, no, I don't remember why I stopped doing it. Some people do it online. When it was face-to-face, 6 hours good. Anyway, we have 2 options: 3 6-hour classes or 2 3-hour classes. Well, not 3 hours, 2.5, because I wouldn't give you a break. Which one you all prefer? Option A or option B? I don't remember why I don't do it 6 hours again, because of the online. B. B. Yeah, I remember that. You see, we cannot have online for 6 hours. I know half of them I will lose all, they will fall asleep on time. All right. Okay, good. All right. Thanks, Ollie. It's not really 3 hours, it's like 2.5 because I wouldn't give you a break, right? All right. So let's take a look at June 2009. Right. Ignore part A. I will show you that at the end of this. Right. So here's what we need to do. The one that's a sketch a graph, right? But I want to leave out the graph drawing part. Right. Let us start from part 2. We'll come back and draw the graph after. Day 1, the limit as x approaches 1 from the right. So which of these functions would you choose? Function, the part 1 or part 2? As you approach from the right. Right, good. You will choose the first function because it's more than, right? So all you're going to do to find as it approach from the right is plug 1 into the first function. As you approach from the left now, here, you'll choose the second function. That's okay? So you don't have to sketch it. Although they ask you, you don't have to sketch it, right? And then check and see if it's continuous. All right? Try part 2 and 3 and then go back and do part 1. Actually, try 1, 2, 3. Right? Try it and see. Remember, it's a straight line. Let's do a quick review for those who don't like drawing lines. Y is equal to mx plus c, right? Y-intercept, gradient. Positive gradient, negative gradient. That's okay? So if I had to draw x plus 2, my y-intercept is 2, and my gradient is positive. So my line will look like that. See how we see? That's all you have to do. Figure out the gradient, positive, negative, and your y-intercept. Okay? The only problem though is if I said x is more than 1, then you have to find when x is 1. So you'll get 3. So you cancel off all of this here. Your graph will look like that. Okay? If I said x is more than 1. If I said x is less than 1, then you take the parts that are scratched off. So you unscratch this scratch line. All right? Try that there for me. Try part B. I'm giving you a few minutes and you'll message what you got for part 2, A and B, and part 3. All right, so sorry there. I'll just do this sketch quickly, right? So basically, for me to get the values, I just plugged in here. X is -1, found for Y, X is 0, X is 1. And I found the Y values. Up here, I plugged in 1 and 2. Right? And the question said they want the domain between -1 and 2. Right? Work out your limits. Tell me what you get. As you approach from the right, what you're getting. As you approach from the left, what you're getting. And is it continuous? Well, they didn't say that, but tell me if it's continuous or not. Oh, how I got the graph, Nathaniel? For the X, for the 1 plus X, I plugged in -1, 0, and 1 and got the Y values and plotted. Right? And then for 3 minus X, I plugged in X is 1 and X is 2. And I found the Y values and I plot them. Right? Right? Why did I put solid? Because on the first part of the function there, 1 is defined, right? Okay, quick question. As you approach 1 from the right, what you getting? Wait, people online no message on me. Brittany, as you approach 1 from the right, what you got? Brittany? Brittany. All right, Brittany has left the building. Grant. Gosh, I asked Grant. Grant, you there? Right, nice job, Aaron. Look how nice this man handwrites, isn't it? Shavish. Good job. Send me all the work, you know, thing, man. Look, I like Shavish. Yeah. How much you got? As you approach from the right. Right? Grant, you not there? Yeah, Brittany, tell me now. As you approach 2 from the right, what you got? Oh, you are taking long. Right, so the answer is 2. As you approach from the right and as you approach from the left, the answer is also 2. Are they the same? Yes, so the limit exists, right? So the limit as x approaches 1 of f of x is 2. Now they ask to deduce that f of x is continuous. So basically, we already proved 1. We have to check and see if f of 1 is defined. Is it defined? Yep, it's defined right here, right? And f of 1 is 2, right? Are they equal? Limit equal to this, so therefore continuous. Well, you should see all of that, yeah? I just skipped out a step there. Right, 2 of them equal, therefore it continuous. Okay, let's do one more like this. Any questions online? Anybody missing? Any question? Justin, Josiah? Are you okay with us, Koi? Which number you use the all time? So how did you get the solid? Oh, this solid part. See here? If you look at the function here, right? It's defined right here. Right? It's defined right there. So you see the one included. So it means that all you have to do is take this part of the piecewise function and plug in 1. So you'll get 3 minus 1 is 2. Right? So it means that f of 1 is 2. F of 1 is 2. Limit is 2. They are both equal. So therefore continuous. That's okay? Justin? Right? So that was part 3 as well, right? Once they could show f of 1 is 2, right? That's what we just did. And both of them equal. All right. Justin, you okay with that? I think any more emotional like this. Fine. Let's go again. This is 2011. Again, leave out party, right? Leave out party. Slightly different. Slightly different. Big man like you got. One 20. Right, only part B, ignore A. So you have to figure out what's f of 2. You have to figure out that it's approach from the right, approach from the left, and they told it continuous. So what do you think B is? So you're kind of working backwards. Who missing? Jude, you get so many answers as yet? Where? What's going on? Some other answers, please. Where is real? Didn't come. Oh, you get this graph paper thing on the iPad, no? A deal. Have iPad? Have iPad? That's good. You can check. So I'm just checking up on the answers for the first part. What you all got for 2? Right? So you're using the first function, right? 2 squared plus 1. 5. Nice. Right, so that's nice. As you approach from the right, what function are you using? The first or the second function? First function, nice. So you'll end up with same thing, 2 squared plus 1, which is 5. So you're going good so far. Yeah? Goodbye again, sure. Right? Finish out 3 and 4. Tell me what you got. Somebody peed on the bed this morning.
No. No, I was sweating so much.
No, that was Pete.
I was sweat. And which side of the bed? On the door bed? On the door bed on the right next to mom.
That was smart. Right, next one. As you approach from the left, you're going to use this function here. So that'll be b by 2 plus 1. Right? So that will be 2b plus 1, right? Now they set it continuous at 2. So what that means is it simply means this. It simply means that when you approach from the right and the left, it's supposed to be the same value. So therefore, it means that 2b plus 1 is 5, 2b is 4, b is 2. That's okay? Really easy, right? There are a few more like that, right? All right. Quickly, let's go back to the handout. Huh? Yeah, I'll share it here. Right, in the handout, we want to continue with simplifying limits, right? Wait. What was the name of that handout again? Module 1, right? Module 3. So we need to be able, look up here, right? There's a slight problem with this. Can you just plug in -2 and tell me what happened? If you plug in -2 here, we have a slight problem, right? Check quick online. Tell me what's the problem. We have a slight problem if you try to do part 1. Did you okay with part B? In part 1, and you plug in, right, you're getting 0, 0, which is undefined. Once you get 0, 0, or infinity on infinity, or something over 0, let's say x over 0, all these are examples of undefined, right? So what that means is that, yes, a limit should exist, but it's not undefined. So we need to be able to simplify this in such a way that we'll get a value, right? And there are three techniques. First technique is factorization. Second technique, if factorization doesn't work, is dividing by the highest power. And the third thing is something called L'Hopital, right? But you're not allowed to use L'Hopital as a solution. L'Hopital is only for checking the answer. Okay. Right. Here you have some rules for limits. Right. You may have seen them already. We could take the k and put the k in front. Right. So if I give you the limit as x approaches a of 5x. Sorry. X approaches 2 of 5x. We could take the 5 and put the 5 in front. All right. You could just factor out the 5. If you have a multiplied, right? If you have the limit of two multiplied functions, it's the same as the limit as x approaches a of f of x multiplied by the limit as x approaches a of g multiplied by g of x. Addition, well, we can find the limit here and then the limit here. Division, same thing here. Limit on top, limit underneath. That's okay. If you have an entire function here, we could say that I'm gonna give you this sum because this is important, right? If I give you something like this, it is the same as writing the limit as x approaches 2 of x or squared. That's okay. So you can put the entire limit or squared, right? There is a question that we're going to do, and you will see square root. So what you could do now, right? What you could do is you could pull the square root on the outside. You okay with that? You can pull the square root on the outside. That's basically the rule. All right. All right. As I was telling you earlier, if you have to simplify limits, you have three techniques. 1, 2, 3 not really legal, but I'll still show you, right? Well, sorry. Yeah, it's not legal at unit 1 level because you wouldn't get marks for it. Right? But I'll show you what to do is differentiation. Differentiate top and bottom. So you factorize or divide by the highest power. Right? And there's one more rule that we need to learn. You let him in. What's that? Who's that her? Is Jill in the waiting room? You sure? Oh, he now come there. All right, he now reach it. I make it sound like I leave the man outside now. Right? Yeah. And these are 4 more special rules that we have to learn. Whenever you see the limit of sine x on x, that value is 1. Whenever you see cos x minus 1 on x, as x approaches 0, that value is 0. The limit of tan x on x is 1.
Make it sound like I leave the man outside now.
Right? And 1 on cos x is 1. So we have to learn those rules, okay? All right, let's jump into one time. Good. Suppose I asked you to work this out, right? Right? You'll recognize, of course, if you plug in minus 1 underneath there, you're going to get 0, right? So you're going to get undefined. So what you can do in this technique here is you can factorize. So if you factor out x, you'll get x plus 2 here, x plus 2 underneath, that'll cancel. And you'll be left with the limit as x approaches minus 2 of x. Plug in the minus 2. Okay? That's the first technique. All right? Here's how you can apply L'Hopital one time, right? L'Hopital is basically differentiating the top and the bottom and then plugging in the answer. The differential of x squared, 2x. The differential of 2x is 2. Differential of x plus 2 is 1, right? And then plug in minus 2. And you're supposed to get the same answer. That's okay? If you still get undefined, you differentiate again. All right? You differentiate top and bottom. All right, so right. Look at this one here. Look at this one here. This next one here, we have a slight problem, right? When you plug in infinity, it undefined. But here's what, we cannot factorize. We cannot factorize and simplify it. So in a case like that, what you do is you take the highest power, which is x squared, and divide every single term by x squared. So you divide 3x by x squared, you divide x squared by x squared, and you divide 4 by x squared, and it will look like this. Then plug in infinity, and you will get 3 over infinity by 1 minus 4 over infinity, right? Anything over infinity is 0, so you'll get 0 over 1 minus 0, which is 0 over 1, which is 0. That's okay? So the answer is 0. Are you okay with that? So if factorization doesn't work, then you divide by the highest power. If both of them not working, then you can do something wrong with the factorization. All right? Because one of them should work. Are you okay with that? Last type. Oh, well, you have 3 to try there for homework, right? Last type is this. If you have to find the limit, I'll write this one over, right? The limit as x approaches 0 of sine 3x over x. The only way we can write the answer as 1 is if you have the same values here. So if you have sine 6x on 6x, then you could use 0. Okay? This and this must be the same. So you see the problem here? We have 3x here, but we do have 3x underneath. So if we put a 3x here, we have to multiply by 3x here. You're saying that 3 and 3 is 1, right? So basically, here's what I'm saying. What I'm saying is this. What we could do is we could multiply by 3 on 3. So you will end up with the limit as x approaches 0 of sine 3x over 3x, and we could factor the 3. And we know that this value here is 1. Right? And that's it. So that'll be 3 by 1. So the answer is 3. And you're done. All right. Any questions online? If no questions, try number 1 and 2. Try number 1 and 2 here, quick, lightly. I'll leave 3 for homework. Try 1 and 2 now, come on. Go outside. Right? That one, I'll give you some more.
No, I was there. No, I want to do that. No, I want to do that. That one. Oh, even this one. Because none of these people. Oh my gosh. Oh, damn.
Right? Remember, you have to always check factorization first. Don't just jump to dividing by the highest power. Just check and make sure it's not working. And then when you try one, you can go ahead and use L'Hopital. Take it in the outside. But don't outside sit on outside you will see. You get a couple.
That's all I did.
Right, didn't that
I did.
outside? Sit down outside. Sit down in the outside you will see. You got you? So which technique worked for the first one? Huh? Divide by the highest power, right? So let's see. So let's check out the first one. You all can message your answers, eh? So 1 and 2, right? So for the first one here, the limit as x approaches infinity, we divide them by the highest power, 3x squared on x squared plus 1 on x squared, 2x on x squared minus 1 on x squared. So that'll be 3 minus 1 on x squared all over 2 on x minus 1 on x squared. Right? So when you plug in infinity, we get 3 plus 1 on infinity, or this one I probably had a mistake in. 2 on infinity. Yeah, I think I put this one back to front. Supposed to be 3x squared plus 1 on. Anyway, 1 over infinity squared, and you get in 3 over 0 on the, you're all getting infinity. Yeah. When you divide by the highest power. All right, that was a bad example. Try part 2. Supposed to be the other way around. 2x plus 1 on top. Right, try number 2. All right, let's check number 2. So more than likely, it looks like number 2 could be factorized. So that'll be x minus 2 on top, x plus 2 underneath. And then you have 2x squared minus 4x. So what we could factor out is 2x. And we'll get x minus 2. This will cancel here. You'll get the limit as x approaches 2 of x plus 2 over 2x. Then plug in 2. So you'll get 2 over 2 by 2, which is 1. Right? Not 0, right? 1. All right. So that's 1. Are you okay with that? Try next one with sign and cross on sign on terminal. Right? That's it for limits, right? The next thing is, which I still might show you today, differentiation by first principles. You okay with this one? Huh? But you follow what to do? So yeah, divide by it didn't work out too good because you still end up with infinity. Right? But yeah, divide by the highest power. And there are a few more that we're going to do, so you will see it. So in the first one, I simply divide every one of the terms by infinity. Sorry, by x squared. Because the highest power is x squared. I divide everything by x squared. And then I plug in infinity. So I've got 3 plus 0 over 0. All right, next one. Try number 1. Take your time. Remember, it must be like 3x on 3x. Huh? So you had to figure out how to get that in there. Right, after a while, you can do this in like 2 lines, but I am going to do all the steps to get it, right? So for you to use the rule, it must be sine 3x on 3x. For you to use the rule, you must have sine x on x. All right. So if you look here, right, I am going to use all the steps, right? I'm going to write out all the steps. Right. So what you see? This first step, of course, is to break it up, right? Using the division. So you'll get the limit as x approaches 0 of sine 3x divided by the limit as x approaches 0 of sine x. Right? Because I want to get 3x here, what I'm going to do is I am going to multiply by 3x on 3x. Because I want x here, I'm going to multiply by x on x. That will not change the value because 3x on 3x is 1. X on x is 1. That's okay? So it will not change the value in any way. So we'll end up with the limit as x approaches 0 of sine 3x on 3x. Right? I'll show you what we're going to do with that 3x just now. By 3x. Divided by the limit as x approaches 0 of sine x on x by x. I cannot just factor out the 3x. But what I could do is this. I could write it like this. The limit as x approaches 0 of sine 3x on 3x multiplied by the limit as x approaches 0 of 3x divided by the limit as x approaches 0 of sine x on x by the limit as x approaches 0 of x, right? Right, you'll recognize that this value here is 1. You'll also recognize here that this value here is 1, right? This is 1, this is 1. So you'll end up with the limit of 3x as x approaches 0, right? Divided by the limit as x approaches 0 of x. We could take the 3 and factor it out. So you'll get the 3 by the limit as x approaches 0 of x, by limit as x approaches 0 of x. And this will cancel. And you'll get 3. Right? 10 years down the road, and we get 3. Right? There is a next method, but I don't like it because we kind of leaving out rules and limits. Some people just divide by, they just divide by 3x on x right here. Right? And I kind of don't really like that because you're not really using rules or limits. And you can't cancel off, of course. All right. Copy down. These are all these steps, right? So yes. Right, but you're still missing some small steps anyway, right? Think about that. The limit of 3x on is 1. Right? The sine 3x on 3x is 1. Right? There's a next way. I don't really like it too much, but I'll also show you. Right? Because you know you want 3x here, you could divide this by 3x. And you could divide this by 3x. Right? You divide in both the top and the bottom by 3x. And you'll write it like this. The limit as x approaches 0 of sine 3x on 3x all over the limit as x approaches 0 of sine x on 3x. But instead of writing 3, you could factor the 1/3. So this here is 1, this here is 1. So it's 1 over 1/3 by 1, which is 3. right? So that kind of a little bit shorter, right? So you could also use that as well. All right, last one. Try sine 4x on sine 5x, right? Last one. You can kind of watch it and figure out the answer. Get the answer? Message answers online. Have a long way you could do it and a short way. Right, correct, Harris. Wait, how come all still messaging there? Oh, I changed it wrong. Wait. Do not message me. Yeah, tried quick message answers. Koi correct. Harris correct. Right, keep sending. Antonio correct. Rajiv correct. Right? Yeah. Yeah. No, can you get? Hurry up. Keep sending. Well, correct, huh? Correct. Right, nice. All correct. All I have there correct so far. Very good. Right, so I just breaking it up. The limit as x approaches 0 of sine 4x divided by the limit as x approaches 0 of sine 5x. You would like to get divided by 4x here, so you multiply by 4x here. Divide by 5x here, so you multiply by 5x. That'll be equal to the limit as x approaches 0 of sine 4x on 4x by the limit as x approaches 0 of 4x divided by the limit as x approaches 0 of sine 5x on 5x by the limit as x approaches 0 of 5x. This value here is 1. So you have to show them now, Kyle. Right? You have to show them there using the rule there. So that value is 1. So now you could write the limit as x approaches 0 of x. And here 5 by the limit as x approaches 0. Right? This will cancel and you'll get 4 and 5. Right? Nice. Okay. So good. That's how you handle limits. All right. There are some with tan and cos and thing, but it doesn't matter. You're just using these rules here, right? Same principle. You're just using these rules right here. Okay. All right. So if it's tan, you're just using the same rule. Tan and sine kind of similar. Cos is a little bit different, right? I think there is one cos in the past papers. Any questions online? Why did you multiply 4x on 4x by 4x, 5x on 5? Right. Remember, the reason I did that is I can't just put 4x here alone. By the way, sorry. This here is the rule, right? 4x divided by 4x as x approaches 0 is 1, right? So I have to get in that form. So the reason why I divided by 4x here was to get in this form. And if I divide by 4x, I have to multiply by 4x because 4x on 4x is 1. And I wouldn't change this answer. If I divide by 4x alone, well, I would have changed the answer, right? That's okay? So I divided by 4x, and then I divided by 5x. All right, nice. Let's try our limits here. Try party quickly. Try party faster. Right, that's the end of limits, right? Next day we start differentiation. Actually, no, we have one more thing to do, first principles. Finish. Usually have to tell as well and check it, right? Finish. Right? So most likely factorization might work here. X plus 3 by x plus 2 on top. X minus 3 by x plus 2. This will cancel. Yeah. And then you're plugging in minus 2, right? I left already limited. Don't leave out that. Yeah? Plug in minus 2 plus 3 over minus 2 minus 3. So I got 1 on minus 5. Right? Minus 1/5, right? Antonio, minus 1/5. Nice. Karina, you okay with that? Zaria, you got that there? Okay with that? Next one. Right, send your answers for this one now, please. Wait, the same thing. Try this one here. This one a little bit harder. Right, you need to remember was a cube minus b cube. Right, that's the only hint I can give you there. You have to remember was a cube minus b cube. Try that quick. Right, just in case you forgot, is a minus b, a squared plus ab plus b squared. All right, let's check this one out. Right, so what are we going to get? We'll get, remember, 8 is like saying 2 cubed, right? So it'll be x minus 2 by x squared plus 2x plus b squared, which is 4. All over, could be factorized underneath. That'll be x minus 4, x minus 2. This will cancel. And then when you plug in the 2, you'll get 2 squared plus 4 all over minus 2. So that is 4 and 4, 8 and 4, 12 over minus 2 is minus 6. Yeah, minus 6 work. Yeah, nice. All right. What do? I could stop here, or I could not stop here. Yeah, let's not stop here. All right, so I'll give you a few more. Well, yeah, you have a few more that you could try. But let's see if I could find the one in cost. Any questions there, earlier? All right, can't find it, but I could find, but there's one that we could still try here, and we're done. So why didn't you scratch off the 8? Hold on, Oh, the reason I scratched the 8 is so I could use the rule a cubed minus b cubed. Remember, they had x cubed minus 8. So I took off the 8 and I wrote 2 cubed instead. So I could use a cubed minus b cubed. All right. Chang, you with me still? Chang, you there? Israel, what's going on? Chang, you there still? William? Last one. Last one here. Take your time, 5 marks for this one. Please don't use any shortcuts. Do all the steps and simplify it out. Okay? If you do any shortcuts, you'll get wrong. Guaranteed. I keep messaging them. Let's see. I have any samples on differentiation? No, I just have this one here. Hold on. I send it in any group now. Right, this is the only sample that I have. That's the one that most teachers may have shared. All right, so let's see what you got. So you have the limit as x approaches 0 of 2x cube. I'm breaking it up one time, right? 2x cube plus 4x divided by the limit as x approaches 0 of sine 2x. Right, usual problem, I want to get 2x here, so I have to divide by 2x and multiply by 2x. Right? That will leave me with, as x approaches 0, of 2x cubed plus 4x divided by the limit as x approaches 0 of sine 2x on 2x multiplied by the limit as x approaches 0 of 2x. Okay, this value here is 1. So we now have the limit as x approaches 0. I could factor out 2x here. I'll get x squared plus 2. And then we divide in by, remember this value here is 1. So we divide in by the limit as x approaches 0 of 2x. Right? So of course, I could take back out this limit and this 2x will cancel. That's okay? Actually, I'm gonna jump that step. I'm gonna just write it back like that. I could write it back like this. The limit as x approaches 0 of 2x over x squared plus 2, all on 2x. So this will cancel. And then I could plug in x as 0, and I'll get 0 squared plus 2, which is 2. Right? If you follow all these steps, you should get this, and then you should get this step here. All you have to do when you reach here is to write it back in the original form. All right? Right? So nice.